Hey, hi, this is Rohit. Welcome back to our channel Rohit Chemistry. So today in this particular video, we are going to discuss about several topics related to water. It means a gel, right? So in this particular video, we are talking about what is the hardness of water and how to remove hardness of water. It means water softening techniques, right? So there are several methods which are used in water softening techniques, right? So in this particular video, we are talking about how to remove hardness of water by boiling, by soda method, by lime method, and soda lime method, and last one is that a zeolite method, right? So let's start. So in this video, we are talking about, first we are talking about what is a water and how to classify water, right? So if we talk about this water, so water can be classified in two types on the basis of chemical composition, right? As we know that H2O is basically water, which is known as a normal water, all right. But if we talk about the D2O is basically known as a heavy water. Right? So what do you mean about this heavy water? The term heavy are used in respect to the hydrogen, right? Why? Because as we know that hydrogen has three isotopes. First is that a protium, which is represented by hydrogen, which is represented by H. Second is that a deuterium, and which is represented by capital D, and third is that a tritium, which is represented by capital T, right? In this hydrogen, number of proton and number of neutron. Number of proton is 1, in the deuterium number of proton 1, and in the tritium number of proton is 1. Number of, if we talk about the number of neutron, then the protium has 0, but deuterium has 1 and tritium has 2. So the atomic number and the atomic mass. So basically atomic number is equal to number of proton. That's why we can say that for the protium, it means the hydrogen, the atomic number is equal to 1. But in case of the deuterium, we know that the atomic number is number of proton. That's why for the deuterium also atomic number is 1. For the tritium also 1. But if we talk about the atomic mass, so the number of protons plus number of neutron is basically number of atomic mass. So that protium has atomic mass 1, but deuterium has 2 and tritium has 3, right? So the three elements are known as isotopes of hydrogen because they have number of protons same but number of neutrons are different, right? In which tritium is a radioactive element. Tritium is the radioactive element, right? And D2O is basically used as a moderator, as a mandak ki taur pe used as a moderator, right? So this is basically heavy water, right? So normal water also can be classified in further two types, right? First is that soft water, and second is that hard water. What do you mean about the soft water and hard water? On the basis of salt which are dissolved in water, we can classify normal water in two types, soft water and hard water. If water has no solvent like calcium and magnesium bicarbonate, calcium and magnesium sulfate, and calcium and magnesium chloride, then this type of water is known as a soft water, right? So there are absent of salt like calcium bicarbonate, magnesium bicarbonate, calcium sulfate, magnesium sulfate, calcium chloride, magnesium chloride. But in case of the hard water, there are some salt which are dissolved in the water, right, and which are responsible for the hardness of water. That's why this type of water is known as a hard water, right? So salt is basically bicarbonates of calcium and magnesium, sulfate of calcium and magnesium, and chloride of calcium and magnesium. Further, on the basis of salt which dissolve in water, hard water can be classified in two types on the basis of the hardness, right? So hard water can be classified in two types. First is that a temporary hardness. temporary hardness. First is that a temporary hardness, and second is that a permanent hardness. Second is that a permanent. Second is basically permanent hardness. Second is basically permanent hardness. Permanent hardness, right? So what is the temporary hardness and what is the permanent hardness? So on the basis of salt which are dissolved in a water, we can classify hard water in two types. If salt like calcium bicarbonate and magnesium bicarbonate, if salt like calcium bicarbonate and magnesium bicarbonate dissolve in a water, then the hardness is known as a temporary hardness. But salt like calcium sulfate, magnesium sulfate, calcium chloride and magnesium chloride, if salt like calcium sulfate, calcium chloride, magnesium sulfate, magnesium chloride dissolve in water, then the hardness is known as a permanent hardness, right? So this is basically classification of water on the basis of chemical composition. We can classify water in two types, H2 and D2. D2 is basically isotope of protium, isotope of hydrogen, which is known as the deuterium, right? That's why this type of water is known as the heavy water, because the mass of the deuterium as compared to protium is the twice, right? That's why. And normal water also classified in two types on the basis of salt which are dissolved in water, that is soft water and hard water. And hard water also classified further two types on the basis of salt, if temporary hardness and the permanent hardness, right? Temporary hardness, it means if the calcium bicarbonate and magnesium bicarbonate dissolve in the water, then the hardness is known as a temporary hardness. But if calcium sulfate, magnesium sulfate, calcium chloride and magnesium chloride dissolve in water, then the hardness is known as a permanent hardness, right? So now we are talking about, so this is basically hardness of water, right? So now we are talking about which technique or which methods that are used to remove the hardness of water, right? So there are several methods which are used to remove the temporary hardness as well as permanent hardness, and there are some specific methods which are only used for the temporary hardness, right? So let's start. So our next topic is basically water softening techniques. Next topic is basically water softening technique, or we can say that removal or hardness of water, removal of hardness of water. All right, so in this method we are talking about soda method, lime method, soda lime method and zeolite method, right? So as we know that there are two types of hardness. First is that temporary hardness, and second is that permanent hardness. Also we know that in the temporary hardness we have bicarbonates. But in case of the permanent hardness we have sulfate and chlorides, right? So as we know that bicarbonate can decompose into carbonate by heating. Bicarbonate can easily decompose into carbonate by heating. That's why we have first method to remove hardness, to remove temporary hardness, is that by boiling. We can easily remove temporary hardness by boiling, right? Second method is that by soda. Soda, it means a sodium carbonate. Soda, it means a sodium carbonate. sodium carbonate. And third method is that by lime. By lime, it means a calcium hydroxide. Calcium hydroxide. Right. So these three methods are used to remove temporary hardness. Right. And for the permanent hardness, we use first method like soda and lime method. Alright, soda and lime method. And second is that a zeolite. Second is that a zeolite, or we can say that permutate. We can say that permutate method. And one another method is that ion exchange method. So these methods commonly used to remove the temporary hardness. Obviously, these three methods also we can also use for the temporary hardness, but these three methods not used for the permanent hardness. It means by boiling, by soda method, by lime method, not used to remove the permanent hardness, right? Alright, so let's start by boiling. It means a temporary hardness, right? So let's start. Our next topic is that how to remove temporary hardness. Our next basically topic is that how to remove temporary hardness of water. In case of the removal of temporary hardness, we have first method is basically by boiling. By boiling. When we boil the water, it means a water containing bicarbonates, right? Then the bicarbonate like calcium bicarbonate and magnesium bicarbonate are decomposed, or we can say that bicarbonates change into carbonates, right? Into carbonate. So the calcium bicarbonate convert into calcium carbonate and some amount of water as a side product, right? And in case of this magnesium bicarbonate, magnesium convert into the magnesium carbonate and some amount of water as a side product, right? But there are problem in case of this magnesium bicarbonate. In case of magnesium bicarbonate, why? Because the magnesium carbonate are soluble in water. That's why magnesium carbonate further arise hardness of water. But in case of this calcium carbonate, calcium carbonate is insoluble in water. Calcium carbonate is insoluble in water. That's why calcium carbonate doesn't arise further hardness into the water, right? But magnesium carbonate further arise hardness of water just because of magnesium carbonate are soluble in water. All right. So our next method is basically soda method. Second method is basically by soda. All right. So by soda method, we can remove temporary hardness basically. So if we have calcium bicarbonate and magnesium bicarbonate, then react with soda, it means a sodium carbonate, similar sodium carbonate, then they form calcium carbonate. This is basically calcium and carbonate. Then they form calcium carbonate and sodium bicarbonate and sodium bicarbonate. All right. So the product will be calcium carbonate and 2 mole of sodium bicarbonate. This salt is basically known as a sodium or we can say the hydrogen carbonate, and this is calcium carbonate. In case of this magnesium bicarbonate are decomposed to this sodium carbonate and gives magnesium carbonate and sodium bicarbonate, 2 mole of sodium bicarbonate, right? Similar, there is magnesium carbonate salt which is soluble in water, so this is problem with this magnesium bicarbonate, right? But in case of this calcium carbonate which is insoluble in water, right? All right, so now our third and last temporary hardness method is basically lime method. So our third is that a lime method. What do you mean about this lime? Lime is basically calcium hydroxide. All right, so when calcium bicarbonate and magnesium bicarbonate react with lime, it means calcium hydroxide, then they form product as a calcium, then they form product as a calcium carbonate, then they form product as a calcium carbonate and some amount of water as a side product. In case of this magnesium bicarbonate, they form a calcium carbonate as well as magnesium carbonate and some amount of water. So these three basically methods which are used to remove a temporary hardness. But there is a problem with this magnesium bicarbonate. Because in this magnesium bicarbonate react with the soda and this lime, and by heating change into this magnesium carbonate, and which is soluble in the water, right? So to remove this particular problem which are arise in the temporary hardness, we need another method, right? And this method is known as a soda lime method, right? So these three methods commonly used in the temporary hardness, how to remove temporary hardness of water, right? So our next topic is basically how to remove temporary and permanent hardness of hard water, right? This is basically our next topic. So in this particular topic, we have first method, that is known as a soda and lime method, right? What is meaning about soda and lime method? In this method we react soda as well as lime, right? And first of all, let me discuss about the two salt which are insoluble in water, right? So there are two salt basically. First is the calcium carbonate and second is that a magnesium hydroxide. These two salts are insoluble in water, right? So we have to target magnesium. Our target is basically how to convert magnesium salt into magnesium hydroxide, magnesium salt into magnesium hydroxide, right? Okay, so now through this method we can get our target, right? So our first method is basically soda lime method, and this particular method, if we talk about this, like calcium bicarbonate, then reaction with soda, we get calcium carbonate and similar 2 mole of sodium hydroxide, sodium bicarbonate. Similar, if we talk about this calcium bicarbonate react with lime, it means calcium hydroxide, then they form basically calcium carbonate and some amount of water. But problem with this magnesium carbonate is that when the magnesium bicarbonate react with soda, lime, or we can say by boiling, we get a common salt in this three method, that is a magnesium carbonate, right? In this soda method, another side product is basically sodium bicarbonate. In this lime method, another compound is that calcium carbonate and some amount of water, and in this by boiling we get a side product as a water, right? So what is the problem with this magnesium bicarbonate and this magnesium bicarbonate? So how to resolve this particular problem? So through this method, soda and lime method, as we can write here, magnesium bicarbonate react with soda. So now after that we react this reaction will react further with the lime. That's why we can convert magnesium carbonate into the magnesium hydroxide, right? It means when the further react, when magnesium bicarbonate react with soda and lime, then we get magnesium hydroxide, then magnesium hydroxide and calcium carbonate, right? It means when the magnesium bicarbonate react with soda, then we get magnesium carbonate, right? And side product as a sodium bicarbonate, right? And the magnesium carbonate when react with the lime, like calcium hydroxide, then we get magnesium hydroxide and calcium carbonate. That's why I write two salt, magnesium hydroxide and calcium hydroxide, because when the magnesium bicarbonate react with first soda and after that lime, we can convert magnesium carbonate in magnesium hydroxide. We can complete our target, how to convert magnesium salt into the magnesium hydroxide, right? So through this method we can easily solve the problem which is arise along the magnesium bicarbonate salt, right? So this is basically soda lime method, right? But if we have a salt of a calcium and sulfate, how the reactions are followed? If we have a salt like a calcium chloride, like a calcium sulfate, if react with this soda Na2CO3, basically we get a calcium carbonate and side product as a sodium chloride. Similar, if we have a calcium sulfate, then react with soda, we get the calcium carbonate and along with sodium sulfate, Na2CO3, Na2SO4, sorry, this is known as a sodium sulfate, and this is basically sodium chloride, and this is basically calcium, this is basically calcium carbonate, Similar, if we have a salt like magnesium chloride and magnesium sulfate and react with soda, then we get magnesium carbonate and 2 mole of sodium chloride, right? And if we have a salt like magnesium sulfate, then react with soda, we get magnesium carbonate along Na2SO4, right? And this magnesium carbonate react with lime calcium hydroxide, gives magnesium hydroxide, which are insoluble in water. That's why we can remove 100% hardness of water, and along with calcium carbonate, which is also insoluble in water. That's why the soda lime method are useful to remove the completely temporary and permanent hardness of water, right? All right. So our next and our last method is basically zeolite method. Our last method is basically zeolite method. So what is a zeolite method? Our second method for the removing of permanent hardness is basically zeolite method. Zeolite method also known as permuted method. Why? Because zeolite is basically minerals of aluminium, silicon and sodium. That's why we can say that are permuted. All right. So what is the chemical composition of zeolite? So chemical composition is basically chemical composition of zeolite is basically Na2 sodium oxide, Al2O3 dot X SiO2 dot Y H2O. So this is basically chemical composition of zeolite, sodium oxide, alumina and silicates, right? All right. In the short form, we can write zeolite like Na2Z, and their Z is basically Al2O3 dot X SiO2 dot Y H2O. All right. So how the zeolite method are useful to remove the hardness of water is basically simple. When the zeolite, it means Na2Z, react with salt of calcium and magnesium, then zeolite replace the calcium and magnesium salt and form a calcium zeolite and magnesium zeolite, right? It means basically zeolite decompose the salt which are responsible for the hardness of water, and this way we can remove the hardness, we can remove the permanent hardness of water, right? So this is basically principle of the zeolite method, right? In this zeolite method, there are a instrument used to remove the hardness. Instrument is basically, we have a container like this, and this container, in this particular container, there is a zeolite bed. There is a zeolite bed. All right. Zeolite bed, and after that we have a gravels. For the purification of water. All right, and through this, for the hard water, through this way we transfer hard water into the tank. Hard water. All right. All right. So when the hard water, when this basically hard water are spread out into the tank, then the salt which are dissolved in the hard water react with the zeolite bed. React with zeolite bed. And the chemical reaction are take place like this. When we have a salt like calcium bicarbonate react with the zeolite, it means Na2Z, then they exchange the cation like a calcium zeolite and 2 mole of sodium bicarbonate as a side product, right? It means calcium bicarbonate are decomposed into the calcium zeolite. All right. So through this we can remove the hardness of water. Now, if we have a salt like a magnesium bicarbonate, then similar magnesium bicarbonate convert into magnesium zeolite and side product as a sodium bicarbonate 2 mole, right? And if we have a salt like a calcium chloride, then similar zeolite react with the calcium chloride and form sodium zeolite and side product as a sodium chloride, right? If we have a magnesium chloride, then similarly zeolite form a magnesium hydroxide, magnesium zeolite salt and 2 mole of sodium chloride, right? Similar, if we have a calcium sulfate and magnesium sulfate, then zeolite form calcium zeolite and magnesium zeolite along with sodium sulfate. All right. But after some time, all right, so after some time, this zeolite bed are stop working because the blocking of the zeolite bed, right? Because after some time zeolite bed become blocks. So remove of the blocking, we need a solution like a sodium chloride. We need a solution like a sodium chloride. So there are another tank to remove, which is NaCl solution, to remove the blockage into the blockage of the tank, right? So through the injector, we inject the solution of NaCl into the tank of a zeolite. Through the injector, there is injector, there is injector. Through this injector, we inject the NaCl solution into the zeolite, to remove the blockage which happened after some time of zeolite bed. Alright. So through this blockage, there is chemical reaction how to remove the blockage into the zeolite tank. So this is basically when the zeolite like a calcium zeolite react with the NaCl, then they form Na2Z and CaCl2. So this is basically zeolite. This is basically zeolite salt, right? And if we have like a magnesium zeolite, then react with this 2 mole of NaCl, then they form Na2Z and magnesium chloride as a side product, right? So to remove the blockage into the zeolite tank, into the zeolite bed, we use a NaCl solution, right? Alright. And to remove this particular salt, we have a sink over here. Alright. And also we have a exit for pure water, it means a soft water. So through this pipe we get a soft water. So this is basically zeolite method which are used to remove completely temporary and permanent hardness. Alright, so this is all about how to remove hardness and what is a hardness, which type of salt responsible for the temporary and permanent hardness and all. Right, so this is Rohit, and I hope you like this video. If you like this video, then don't forget to subscribe my channel Rohit Chemistry. See you soon in the next video. Alright, bye.